In every walk with nature, one receives far more than he seeks. Ladies and gentlemen, in the golden light of a hopeful morning, we gather not just as seekers of knowledge, but as stewards of a greener tomorrow. We breathe in an era where technology must touch the stars, but with feet grounded gently on earth. With immense joy, I welcome you all to the National Seminar on Sustainable Computing and Cosmic Innovation, Pathway to Green Technology for Business Evolution, jointly organized by the Department of Computer Science and Science in association with IQAC and IAC. This is more than just a seminar. It is a confluence of ideas, innovations, and intentions where science serves society and technology nurtures the planet. Where words fails, music speaks. Let us begin this august gathering by invoking the divine blessings of God. I now invite Manu Francis to present the praise song.
My Lord and my Savior, there is none like you. All of my days, I wanna praise the wonders of your mighty love. My comfort, my shelter, tower of refuge and strength. Let every breath, all that I am, never cease to worship you. Shout to the Lord, all the earth, let us sing. Power and majesty, praise to the King. Mountains bow down and the seas will roar at the sound of your name. I sing for joy at the work of your hands. Forever I love you, forever I stand. Nothing compares to the promise I have in you.
As the lamp light up the darkness, let knowledge light up the future. The ceremonial lighting of the lamp is a timeless Indian tradition that signifies the dispelling of ignorance and ushering of enlightenment. I humbly request our dignitaries to illuminate the lamp and ignite the flame of wisdom and innovation. Hospitality is not to change people, but to offer them space where change can take place. To formally welcome this distinguished gathering and set the academic tone for this day, I now invite Mrs. Santilakshmi, Head of the Department of Computer Science, for the welcome address.
It's an immense joy and honor. I stand before you today to extend a heartfelt welcome to the National Seminar on Sustainable Computing and Cosmic Innovations Pathways to Green Technology for Business Evolution. Jointly organized by the Department of Computer Science and the Department of Science in association with IIC of Christ College of Science and Management. This seminar is a significant initiative aimed at ensuring the confluence of sustainability, technology, and innovation. A conversation both timely and necessary as we move toward a future that demands green alternatives and intelligent solutions for business evolution. To commence this grand occasion, it's my privilege to first extend a warm welcome to our respected Reverend Father Jose Tota CMI, Manager, Christ Group of Institution, whose leadership across the institution has consistently inspired innovation, discipline, and a strong foundation in values. Father, thank you for your presence and blessings. I also take this moment to warmly welcome our esteemed principal, Reverend Father Jose CMI, a visionary leader whose unwavering support and guidance have been the backbone of all our academic and co-curricular initiatives. We welcome you, Father. We are truly honored to have with us two eminent personalities as our keynote speakers, renowned experts in the field of science, innovation, and business leadership. A very special welcome to Dr. C.S. Talley, Professor, Indian Institute of Astrophysics, Bengaluru. Sir, your insights into cosmic sciences will undoubtedly open our minds to broader and deeper dimensions of sustainable innovation. Welcome. I'm delighted to welcome Dr. Matthew J. Manimala, former Director of SAN and former Professor, IIM Bengaluru, a renowned academic and a thought leader in management and entrepreneurship. We welcome you, sir. Also, a warm welcome to Dr. P. Rajalakshmi, Head Department of Science, one of the key members of the organizing committee. Thank you, ma'am, for being a strong support in executing this seminar. Welcome, ma'am. We are also joined by a renowned panel of eminent academicians and industry experts who will be leading today's technical sessions and evaluating the research presentations. It's my privilege to welcome you all individually. I extend a warm and respectful welcome to Mr. Ajay Vaishnav, Software Quality Engineer and Automation Tester, Infosys, Bengaluru. Also, a hearty welcome to Mr. Harshavardhan Singh, Associate SAP AP Consultant, Accenture, Bengaluru. I acknowledge the presence of Dr. A. Kavita, Assistant Professor, Government Women's College, Hosur, Dr. Mohammad Imran Khan, and Dr. Imran Pasha, Scientific Officers, State Forensic Department, Karnataka. We are honored to have you with us today. Finally, I now extend a warm virtual welcome to Dr. Father Jitu Matthew, Assistant Professor, STCET, Pare, and Dr. Sister Bindu Jat, Associate Professor, Nirmal College, Machuka, Kerala, who are joining us online. We are grateful for your academic contributions and truly value your participation. We are truly grateful to each of you for your esteemed presence and for the valuable contributions you bring to today's discourse. Your involvement will undoubtedly enhance the quality and the impact of this seminar. I also extend a heartfelt welcome to all the paper presenters, dear students, faculty members, researchers, and participants from institutions across the nation. Your enthusiastic participation adds immense value to this academic congregation. May today's seminar spark innovative ideas, ignite meaningful discussions, and inspire sustainable transformations in computing, cosmic science, and green technology. Once again, I welcome you all at it. Thank you.
Thank you, man. We welcome you too. A leader is one who knows the way, goes the way, and shows the way. We are blessed to have with us our visionary leader whose guidance continues to inspire excellence. I now request Reverend Father Jose Tortadel CMI, Manager, Christ Group of Institution, to deliver the inaugural address.
Reverend Father Principal, James George CMI, and our dear professors, Dr. Matthew J. Manimala, Dr. C.S. Stalin, Harshvardhan Singh, and Ajay Vaishnav, and the head of the Department of Computer Science, Ms. Rashmi, and Rajrashmi teacher. All the respected dignitaries of the dais, all the faculty members, and dear students. I wish everyone a very good morning. Today, we are fortunate to have a very important seminar on topics computation technology and innovative, cosmic innovative science. So many people are going to present their papers, their valuable contributions to science and technology, and they are shaping the future of, we can say, millions of talented people. We know that after our independence in 1947, so much development has taken place in our country. At the time of independence, we know that development was very scarce. Everywhere we noticed starving people, homeless people, wandering here and there, not knowing what to do, where to go, and whom to ask. But from that situation, we have gone a long way. Now we are in 2025. During our independence, we were an underdeveloped nation. Now we can definitely say we are a developing nation and almost near to the developed nations. Now we can catch up with the technologies around the world, and it is up to our fingertips, so that we enjoy today a lot of facilities and conveniences that were not there at the time of independence. Now we have reached the moon, and we are striving and developing technologies even to go to the sun. We are living now in an artificial intelligence world. That means even the human power, that is the most important power, we know that, is slowly replaced by artificial intelligence. So we are very fortunate compared to those people, we can say our grandparents or great grandparents, and even some of our parents. So I congratulate the principal, the computer science and management department, and IAC and the IQAC for organizing this important national seminar. I wish all the best to everyone, and I request everyone to participate eagerly in this national seminar, and we will be receiving a lot more newer and newer ideas and technologies, and that will improve and increase the span of our knowledge, and we will be able to live in a very advanced world. So wishing you all the best. I conclude and I declare this national seminar open. Thank you. Thank you.
Thank you, Father, for your inspiring words. I kindly request the dignitaries to occupy the seats in the front row down the stage. To extend our warm welcome to the first keynote speaker, I invite Ms. Teja from 3rd BSc to the podium.
Good morning, everyone. It gives me immense pleasure to introduce a distinguished guest of the day on the much-awaited National Seminar on Sustainable Computing and Cosmic Innovations, hosted by Christ College of Science and Management. Dr. C.S. Talon is an esteemed astrophysicist and professor at the Indian Institute of Astrophysics, Bengaluru. With a distinguished academic background, including a PhD in physics from ARIS, Nainital, Dr. Stalin has made significant contributions to the field of high energy astrophysics and active galactic nuclear research. Over the course of his career, he has authored more than 200 research publications, averaging over 4,000 citations and maintaining an impressive edge index of 38. His research spans a range of topics including optical and gamma ray variability in AGMs, quasar surveys, and reverberation mapping. Dr. Stalin has mentored numerous PhD scholars and postdoctoral fellows and has participated in several international collaborative projects including Indo-French, Indo-Polish, and Indo-South African research initiatives. He has also played key roles in India's major space missions such as AstroSat and ExpoSat, serving as Deputy Project Manager and Science Working Group member. A life member of the Astronomical Society of India and member of the Indian Astronomical Union, Dr. Stalin has been recognized for his scientific excellence, including receiving the Best Thesis Presentation Award from the Astronomical Society of India. We are privileged to have Dr. Stalin as our guest and look forward to his insights and contributions to the seminar. Once again, we welcome you, sir. Thank you.
Thank you, Ms. Teja. It's an honor to introduce Dr. C.S. Stalin, Professor at Indian Institute of Astrophysics, Bengaluru. His insights into cosmic innovation and sustainable computing promises to spark paradigms. I welcome you, sir, to deliver your address.
Good morning to all the audience here. So I'm thankful for the invitation, and so respected Father Jose is the chair of the group of institutions. Respected principal Father, respected Dr. Matthew Manmala, who is the former director of SIM Bangalore, Dr. Rajalakshmi, the head of the Department of Computer Science, Dr. Rajalakshmi, the head of the Department of Basic Sciences, and all other dignitaries present here. So it's a privilege to be here for this meeting on sustainable computing and cosmic innovations, pathways to green technology and business revolution. So I could see an amalgamation of people coming from different disciplines, science, commerce, computer science. So I would say it's a thing where all the people are brought together. So nowadays we cannot grow by concentrating only on science or technology or business. So now everything is closely coupled, and society has to give people to all these upcoming fields. And if you talk, the people who become entrepreneurs and develop business models, they have to give back to the system itself. So it's a close coupling between all these different branches of science, technology, and commerce. I would say it's a complex feeding and feedback process. Society has to feed, and the feedback also has to come from the top to the society. Currently, as Father rightly said in his inaugural meeting, if you compare 50 years before, we have progressed much in science as well as technology. We have currently reached a position where we can send missions to moon, we can send missions to sun, as well as missions to study stars and galaxies. So we have progressed very much in terms of space sciences as well as basic sciences. And I think the young minds who are gathered here, there are lots of opportunities for these people to contribute to the society. And the society as well as the country is in urgent need of great minds to take up leading projects which are going to come up in the Indian scenario in the next 10-20 years. So I think the time is rightly set, and I would emphasize that the administration or the college has done a great job by bringing all these young minds so that they get to know what are the recent advancements in the field and they can make significant contributions in the coming years. And moreover, the current scenario is that it's difficult to grow independently and different technologies have to come together to have a sustainable growth in the future. So I wish all the participants a great success in this one-day meeting. And with these words, I will just try to move on to my presentation, where I plan to give a glimpse of, because I work on astronomy, so and this field may be new to many of the participants who are here. So I would try to give a feel of what astronomy is all about, what path we took from the many hundreds of years before to the time what we are currently in, and what we intend to see in the future in the Indian scenario. So I would try to give you a feel of what the field of astronomy is. So with these words, I would like to start my presentation. Thank you. Okay, so I have just gave my title as from balloon to. So if you talk of astronomy, because if you ask me as a person, till I finish my MSc, I have no idea what astronomy is. Because those days were completely different. Because we have to only survive for our day-to-day activities. That is the time of survival. Now, even if you take a small kid, they know about, they read papers, they see TV, they are much more what? Informed than what we were there when we started our career. So, give a glimpse of the subject. So, when you talk of astronomy, it's a fundamental science motivated by man's curiosity. So, here I would give an example of the Egyptian astronomy, because the Egyptians initially they depended on only the Nile River. So what they noticed, whenever they noticed frequent flooding of the Nile River. So when they tried to correlate these happenings, what they noticed was whenever the Nile River is flooding, they used to find a bright star on the eastern horizon. So based on these observational findings, they are just observing the sky. The concept of calendar came, and they also try to have increased interest in watching the night sky. So the curiosity or the astronomy, what we call now, is driven by man's curiosity to understand what he sees in the sky. And if you talk of what are the benefits of astronomy, doing astronomy in okay, so if you talk of the benefits of astronomy, in the short term, I would say that it's nil. But in the long term, it has contributed a lot to technology, economy, as well as society. So if you talk of day-to-day applications, the development of optics as well as the electronics, this has become essential for our day-to-day activities. For example, PCs, mobile phones, communication satellites, the GPS, solar panels, all these things have some connection to astronomy. The second important point is on the survival of species. For example, what is the influence of sun on the climate change? Second contribution is what is the dynamics of solar system objects? Is there any threat to these objects to humankind? The third contribution is defense satellites. So I will tell you, when you talk of astronomy, we need to have telescopes. So telescopes will point towards the sky, whereas defense instruments will point towards the ground. When you talk in terms of industry, Kodak film you must have seen long back. I do not know whether these young people who are sitting here must have seen Kodak films. So they were created for solar astronomers to study sun. and now it is having wide-ranging applications in medical field, photography, etc. The second point is charge-coupled devices. They were devised for astronomy in the 1970s, and now you will not realize all the mobile phones you have these cameras, so they are basically CCDs. Then when you talk of radio astronomy, communication, data processing, these things were developed for radio astronomy. Now this is having wide-ranging applications for humankind. Let us come to software. You must have heard about IDL, interactive data language. So these softwares were initially developed for astronomical purposes. Now these softwares are finding wide-ranging applications in industry. For example, I will tell about IDL. This is widely used by General Motors to analyze the car crashes before the product comes to the market. Second, the aspect is telecommunication. There I specifically mentioned about one software called IRAF, interactive processing, some software developed for optical astronomy. That software is also finding wide-ranging use in telecommunication companies. Finally, for humankind also, we are able to predict seasons, which is very important for this thing. The other thing what I want to focus is on Wi-Fi technology. Nowadays, without Wi-Fi, there is no life at all. So you go to the airport, you see everywhere people ask Wi-Fi. And this was technology transfer between astronomy and industry. And the main contribution to Wi-Fi come from radio astronomy, because astronomy also comes under many branches. Say for example, optical astronomy. This branch of astronomy deals only with the optical photons coming from the sky. Then we have radio astronomy that deals with the radio waves coming from the sources. Then infrared astronomy, X astronomy, gamma astronomy. These are different branches of astronomy. They use different technologies as well, because the technology used to detect photons from these different wavelengths are different. And now, when you talk of communication, scientists in Australia developed a technology to transfer data or information wirelessly. That is now what is called Wi-Fi, and this Wi-Fi is used to exchange information between networks and portable devices. The final thing what I want to focus is on imaging. This is also a technology transfer between astronomy and industry. I have mentioned about Kodak films. I also mentioned about charge-coupled devices, and this got also the Nobel Prize in the year 2009. Now I will take a quick walk through about what astronomy is. So astronomy is basically deals with the study of objects in the universe. It can actually answer two things. Basically, it will tell where we fit in the history of the universe and where we are in the universe, in space. So I will demonstrate this by a few examples. So if you take an image of this region, say a photograph having a 50 by 50 size, you will be able to see all these rows, the vehicles which are parked, all those things you will be able to see. Now what I do, I zoom this image by a factor of 10 or 20, and I see a region around 1 mile by 1 mile. So you will see an image like this. Now if I again image a region of 160 by 160 kilometer, maybe the grace color may be a dot in this picture. Again you zoom by 10 times, so you are seeing a region of 1 by 6 into 10 power 4 kilometer by 1.6 into 10 power 4 kilometer. So if you take a photograph, you will see only one object. Then again if you zoom in further, you can see you span a region which is of 1.6 into 10 power 6 kilometer by 1.6 into 10 power 6 kilometer. The earth is seen as a dot in this image. Again zoom in further, so you are able to see a region of 1.6 into 10 power 8 by 1.6 into 10 power 8. So you will be able to see here the sun and one or two planets. Again if you zoom by a factor of 100, so this is 1.6 into 10 power 10 by 1.6 into 10 power 10. So you will be able to see more solar systems. Again in the same exercise, let us zoom in further, 10 power 12 into 10 power 12 kilometer. The sun is also a star. But if you go and see the night sky, you will see many stars in the sky. But if you take a photograph will be able to see only the sun there, which basically means the distance between any two stars on the sky is much larger than 1.6 into 10 power 12 kilometer. Again, you zoom in further, so you will see, you will be able to see a few objects. Now you span a region of 1.6 into 10 power 16 kilometer. If you take an image, you get an image like this. This is what is called a galaxy. So we talked about stars. Now we come to a system called galaxy. Galaxies are nothing but a collection of billions of stars put together, bound by gravity. So again, you go to a region of 1.6 into 10 power 18 kilometer. Here, in this image, every dot is a galaxy. Every dot is a galaxy. Again, you go to 10 power 20 kilometer. So this is what is called a galaxy group. Many galaxies will be put together. And if you see a region of 1.6 into 10 power 22 kilometer, this is what is called the largest structure of the universe. The large scale structure of the universe has a image like this. And when we talk of astronomy, the units what we use is astronomical unit. One astronomical unit is 1.496 into 10 power 8 kilometer. So when you talk of astronomical unit, this is the mean Earth-Sun distance. And we also talk about light year. This is of this kilometer 10 power 12 kilometer, and we also talk in terms of parsecs. These are some of the units used in astronomy. When you talk of scales, astronomers deal with subatomic particles to the universe. So the scale is of the order of 10 power minus 10 meter to 10 power 20 meter. These are the scales used in astronomy. And when you talk of astrophysics deals or is a combination of astronomy with a theoretical understanding of the processes which are happening in the celestial sources. This is what is called astrophysics. And who are astronomers? Astronomers are the people who deal with the study of the observation. So when we talk of the currents, they go from 10 power minus 30 kilogram to 10 power 50 kilogram. This is the mass scales what we deal with. When we talk about the history, till about 100 years ago, astronomy was centered only on the visible part of the spectrum. For science people, the visible region is about 4,000 to 7,000 angstrom unit. This is the visible window. And 100 years before, astronomy was only focused on the visible band of the spectrum. And it all started with the human eye. And as I told you, it was motivated by the man's curiosity to understand what he sees in the sky. Coming to the Indian context, India too has a rich heritage. As I told you, astronomy started with human eye as the main instrument. So these are the different regions of the spectrum what we deal with, because as I told you, any source in the sky will be emitting radiation from low energy radio waves to high energy gamma rays. So to understand the system in totality, we have to study the radiation from radio waves to gamma rays, and each of these waves have to be studied using different techniques, because the technique used to detect optical photons will not work for the technique used to detect what? X-ray or gamma ray photons. And this is one which you notice in your day-to-day activities. So in our young days, our parents or our older people used to ask us to go out and see the stars are twinkling. But have you ever thought about why these stars are twinkling for the students? You must have seen the stars twinkle in the night, right? Have you seen that? Have you ever thought why it is happening? Okay. So what happens? These stars are very far in the space. Okay? So the photons emitted by the stars have to travel a long distance to the observer, to reach us. And these photons have to travel through the Earth's atmosphere. And as you know, the Earth's atmosphere is not okay. And as these stars are at infinite distance, the radiation coming from these stars can be considered to be wave parallel waves. So now consider a scenario that wave parallel waves are coming in the atmosphere. The atmosphere is not stable, it is highly turbulent. cross plane. So this leads to the tuning of stars. And scientifically, this causes three effects. One is called simulation. Simulation is basically a change in the intensity. The second thing what it does is it causes image blurring. The atmosphere is not stable. The image will become blurred. Okay. The third thing is there will be change in the image, there will be image motion. Okay. So because of these three scientific reasons, the stars appear to be. And to do astronomy, one has to select a site or one has to select a place where the atmosphere is nearly more or less stable. Otherwise, if you put a telescope in some place where the atmosphere is highly turbulent, you will not be able to serve the purpose because your purpose is to detect photons coming from the sky. Now let us come to the next question. I told you planets will be, right? But if you go out and see the stars, but if you go out and see planets will not be. So why? Because the same analogy can be applied to planets also, right? So why planets are not twinkling? So science students, anybody? Okay, so see, planets are nearby objects and stars are very far. Okay, so what we can do, the planet can be thought of as a collection of what? Many point sources. Okay, and each point source each point source will undergo this effect, and when we put the effect of all these objects, so that they get cancelled out. So the average position and the brightness remains unchanged. So because of this reason, the planet never appears to change in brightness. Okay, let's keep it. Let us go to human eye as a telescope. As I told you, astronomy started with human eye only. So human eye can be considered a telescope. So when you talk of telescope is nothing but an instrument to collect the photons. So your eye also has a diaphragm. So photons enter through the eye, and these photons will come to your focus also. That's what you are able to see the objects in the when you are walking or moving. So when you talk eye, the eye is a camera with a focal length of 8 millimeter. So science students will know what is focal length right now. Okay, focal length is 18 millimeter, and the thing is, eye has a variable aperture size. This you must have realized when you come in a bright light field, you will what? Skew the eye, and if you enter a dark room, what happens? The diaphragm expands. So that's a variable aperture size, and eye is also a good. It can be a good focusing things. It's also a powerful image processing system, and you can also identify the object. So these are some of the features of eye as a telescope. Now if you go and see night sky, you see objects like this. So some are what? Some are blue in color, some are red in color. This have you noticed in the sky? You go out and see the sky. Are all the stars same color? Have you ever noticed? Some will appear blue, some will appear red, some will appear white. Okay. Anyway, and what is a star? So the sun is also a star. So what is sun? These stars are nothing but a collection of gas held together with gravity. So what happens is a collection of gas. Because of gravity, what? It compresses. So as due to gravity, when it compresses, the density increases, temperature also increases. So this compression cannot happen indefinitely because as the temperature increases, it's mostly and helium. So as the temperature increases, at some point the hydrogen starts burning. Okay, there is 4 hydrogen atoms combined to form helium nuclei, and this process there is some mass loss which will be converted to radiation. Okay, now you imagine a system. The whole system is getting compressed because of gravity. Now nuclear fusion is happening in the core, radiation is coming out. So there will be a balance between gravity which is forcing in and radiation which is forcing out. So when this balance is reached, we say we tell a star is born. So these fellows are in hydrostatic equilibrium. And what are the parameters we can measure? We can measure the temperature, we can measure the temperature of the star, we can find the distance of the star, we can find what is the chemical composition, what these objects are made of, and we can also measure the brightness. These are the few parameters which we will be able to measure, and from these measurements we have to make some inference about the properties of these objects. Now, I asked a question, why these stars are in different color. So I will bring you an analogy. You take an iron rod, okay, you heat it. So the iron rod will become red hot. Red hot means what? It is emitting low energy photons. Low energy photons means they are emitting larger wavelength photons. Lambda is larger. Then again you heat the rod. What happens? It becomes yellow hot. Again heat it up. It becomes blue hot, which means it is emitting high energy photons. That means shorter wavelength photons are emitting. Okay. So that means as you increase the temperature, more and more blue photons are coming. This is an analogy of heating iron rod. Now you apply the same analogy to stars. What happens? So you must have learned about Planck's radiation law, right? All these people must have learned. At the BSc level, plus 2 level, they must have learned Planck's radiation law. So the radiation coming from stars can also be approximated by Planck's law. And as you see, emission is a function of wavelength. And if you look into the Planck's equation, as the temperature increases, the peak wavelength of emission shifts towards shorter and shorter wavelength. That's what is shown here. You see here, this is a star which is having a temperature of 3000 Kelvin. The peak emission is happening in the red band of the spectrum. Now consider a case where the temperature goes from 3000 to 5500. The peak wavelength shift towards shorter wavelength, it becomes yellow color. And if you increase the temperature further, say 10,000 Kelvin, the peak shifts towards shorter and shorter. That means if you see a blue star, the temperature, you can blindly tell the temperature will be roughly 30,000 Kelvin. If you see a white star, the temperature will be typically 10,000. And if you see a red star, it is the cool star. The temperature is of the order of 3000 Kelvin. So basically, the color of the star gives some indication of the surface temperature of the star. So these are some of the examples. So now, what are information you can gather? You see a sun. You want to study the sun. Because you want to know what is happening in the sun, right? What are observations you can do? You can measure the brightness. That is one measurement. Second measurement, the science students must know, if you have a radiation, if you disperse the radiation, you see what is called a spectrum. And in the spectrum, you see lines in the spectrum which give some information of the chemical elements present in the star. So by analyzing the photons as well as by taking the spectrum of the object, you will be able to gather inference on what is happening in the star. So astronomers have only two tools. They can either collect the photons or they can disperse the photons. And using these two tools, they will be able to study the physical processes of objects. Now, I will try to bring one more concept. It's called the resolution of the eye. What is resolution? It is the capability to see two objects separately. So, I will give an example. And this goes by 1.2 lambda by d. D is the aperture. Lambda is the wavelength. So, here is a simple example. You have a 6-inch telescope and you have a 1-meter telescope. There are two telescopes. The diameter is only different. Okay. So, if you use a 6-inch telescope, two objects will be viewed close together. So, you will not be able to separate them. Alternatively, using a 1-meter telescope, you will be able to separate two objects separately. And then your measurements will be more accurate compared to what you see by 0.15 meter. So we talk about human eye as a telescope. Now, as time progressed, technology also improved, and people moved from naked eye astronomy to astronomy using telescopes. And this happened by Galileo when he found telescopes. And here I have shown an example of how astronomy is done by telescopes. So you see, I told you, eye is a telescope. Eye is a small aperture, right? So since eye is having a small aperture, it will be able to collect less and less number of photons. It is like a bucket. You have a big bucket, you will collect more rainwater. Correct? So if you have a big telescope, you will be able to collect more photons. If you can collect more photons, you will be able to detect faint and faint objects. Okay, these are the advancements. And now we move from Galileo to Newton. Because as I told you, Galileo used lenses. This people must know. You see, if you have a lens, plane parallel waves will be falling on the lens. It passes through the lens and comes to a focus. Right? This is what lenses are used. Now, if you go for bigger and bigger telescopes, you have to use bigger and bigger lenses. And if you use bigger and bigger lenses, you can support the lens only on the ridges. Because light has to come through one end and fall on the other end. Right? So the lens can be supported only on the edges. So if you go for bigger and bigger lenses, there will be lots of deformation will happen and optics will become bad. And what this Newton did, he told instead of lenses, we can use mirrors. That means mirrors will be used, photons will be coming from one end, it falls on the mirror and comes to your focus. So the advantage is you can have as big mirrors as possible because the whole mirror can be supported from the back. Okay, but anyway, I'll give you one slide where technology has advanced so much. So these are some examples of refracting systems. This is a lens. Light comes, it comes from the detector. Okay. These are the cases of reflecting systems. We have mirrors. Light comes here, gets reflected and comes to your focus. So I said, this is another quality to judge how powerful a telescope is. You can consider telescope to be a light bucket, and bigger mirror means bigger bucket. We will be able to collect more photons. Then I will move on the journey from eyes to electronics. So when people normally do astronomy, older days they see through eye, and whatever they see through eye they used to record it by hand. Because I cannot store the data. I cannot store. I cannot put all the memory together because we will lose information. Whereas when you replace eyes from electronics, you will have detector systems mounted on the telescope. When you have detector systems, we will be able to focus the detector long because through eye you cannot see because eye flickers. You will not be able to completely stare an object. Whereas if you have a detector, telescope is there, detector is there, photons can get accumulated, and you will be able to store information. Okay. Now, one point I want to tell because for astronomy we want telescopes, but a telescope cannot be placed anywhere. For example, I cannot put a telescope in Malur because here the sky is so bright that the terrestrial lights will pollute the sky. So sky becomes bright, and astronomers want to correct small and feeble photons. First is we have to choose a site which is very dark. Second thing, as I told you, the atmosphere is disabled. Second important thing. Third thing is you must have a telescope. You must have a site. The number of clear nights are more. In 365 days, if 200 days it is raining, you cannot put a telescope there because the investment is lost. Because you cannot dump crores of rupees to put a telescope. Ultimately, sky is not there. You cannot put a site in a telescope where it is mostly cloudy. So before putting a telescope, people try to do lots of site survey to identify a suitable place where the number of skies are more, number of clear skies, and the atmosphere is more or less stable. So these are, and when you see a typical site, they look like this. Most of the optical telescopes are located dry sites like mountain tops because we have to avoid the habitation also. If more people come, they will have electricity. So we cannot avoid that. So they will pollute the sky. And this slide I just want to focus because you see doing astronomy, there is no immediate reward. Suppose if I do business, I invest some few crores, I can get the reward quickly. It's possible. But in the case of astronomy or doing real science, the benefit is really late. So for this, I just put this quote: preserving knowledge is easy. Transferring knowledge is also easy, but making new knowledge is neither easy nor profitable in the short term. But it will have benefit in the long term. Fundamental research proves profitable in the long run, and as importantly, it is a force that enriches the culture of any society with reason and basic truth. I put this just to drive home the message that astronomy has also started to get recognition from people. So I just put two slides. The Nobel Prize in the year 2019 came to astronomy for two important things. One thing is for theoretical studies on cosmology. The second thing is on the discovery of an exoplanet. So this got the Nobel Prize in 2019, and we got another Nobel Prize in the year 2020. This is about the discovery of black holes. Okay, and these things never came easy. This was based on an experiment which ran for 10 years. They did an experiment for 10 years, and finally they could tell that every galaxy in the system has a black hole. So this was the prize for 2020. This is one slide. I just want to focus on resolution. I told you resolution is 1.2 lambda by t. As we increase the aperture of the telescope, it will be small. But it is not true, because here is an example of a 8-meter telescope. 8 meter means the diameter of the primary mirror is 8 meter. On the right hand side is an image of the same source taken at 2.3 meter telescope. The difference is this is in the ground and this is in space. See, the same object taken from an 8 meter telescope. The same source taken from a 2 meter. One is in the ground, other is in space. So the problem is, telescope you will not be able to read atmosphere. Your photon has to travel the atmosphere. Whereas if you go to space, your resolution will because you are not limited by the atmosphere. But it is not very simple. I just give a comparison. Ground-based telescopes are located at high altitudes. They are located in space. Traveled by atmosphere. Space telescopes are not traveled by atmosphere. Resolution is limited by seeing the instrument. It is cheap. Ground-based astronomy is cheap. Space missions are expensive. In the ground, if you have an instrument, if something repair happens, you will be able to correct it. Whereas in the case of space missions, if something happens, it is lost. I will show you one example of our instrument that we lost an instrument in space. As an example, technology is now available to have large telescopes in, but having large telescopes in space, we don't have technology as of now to launch big missions. So these are some of the facilities our institute is having. This is the facility in Kabul, and these are the telescopes in Kabul. These are some of the instruments available in the observatories run by the Indian Institute of Astrophysics. These are some of the facilities available in other institutes in the country. This is the facility available in the Physical Research Laboratory in Mount Abu. This is the facility available in Bengal. So we are just trying to give one example. See, for doing astronomy, you need to have a mirror. Right? Photons from the sky come, it falls from the mirror, gets reflected. That's the fundamental thing. Now there is a technology called liquid mirror telescope. And there is no need to have mirrors, because mirrors means you have to have a huge weight. Now this facility got opened only 2 years back, and what they do, there is no need to have mirror. What they do, they will fill mercury in a bowl, and they will rotate the bowl with certain speed, etc. So that as the bowl rotates, the mercury will take the shape of a mirror, and whatever photons will come will fall on the mercury mirror and then get reflected. But the difficulty is that mirror will only see a single point. You cannot move the water. Mercury, because mercury will tilt. So there's a disadvantage, but it's a very cheap instrument. And we also have a telescope in Kodaikanal. This is to study only the sun. And there's an effect called inverted effect which is stored in Kodaikanal. And the government of India brought out some stamps to commemorate this. Here I show some pictures of radio astronomy. Before I showed about optical astronomy, these are some things about radio astronomy. We have a facility in multi-radio telescope. There is something called the Jain Meter Wave Radio Telescope. It is operated by the National Center for Radio Astronomy of the Tata Institute of Fundamental Research. This is a facility called High Altitude Gamma Ray Astronomy. This is a facility in Ladakh, in Leh, Jammu Kashmir. This is how it goes. This is astronomy in India now. We have facilities in optical, infrared, and radio by the Indian Institute of Astrophysics. These are some of the facilities we are operating. This is another institute called Aryabhatta Research Institute of Observational Sciences. They have 3 telescopes. One is called Sambhavan Telescope, Devasar Telescope, and International Nuclear Telescope. Then we have a physical research laboratory. We have telescopes operating in the radio, and we also have some facilities operated by Baba Atomic Research Center. They have these instruments, and in space, we have something called AstroSat. This is a collaboration between ISRO, the Canadian Space Agency, Institute of Astrophysics, Tata Institute of Fundamental Research, IUCA, etc. This is the situation now. And what do you foresee in the future? There are plans to have something called a 30-meter telescope. Whatever you saw is a 2-meter telescope is what we are having. So India has gone into an agreement with 5 countries are joined together. The idea is to build a 30-meter telescope. The diameter is 30 meters. And we don't have the technology to have one 30-meter. So what they are planning now, they will plan to have 4 92 1 meter mirrors. And these 4 92 mirrors will be sandwiched like honeycomb. The final structure will be a honeycomb structure. So all the 4 92 mirrors will be sandwiched, and the final thing will be the size of a 30-meter telescope. And India is a 10% partner. And in the project cost that time was 1,300 crores, and now because of cost restriction it can go up. Okay, so India is a 10% partner, which means of the 10% of the nights India will get. We can use 10% of the nights. And our institute has a commitment to deliver 100 mirrors. So we have to deliver 100 mirrors, and the mirrors are specifically made in a lab in Hoskote. We have a facility in Hoskote, and they have established a lab to make these mirrors. The mirror blank will come, we have to polish the mirrors, grind the mirrors, and send it to US. So they will assemble them. And there is a project called NLOT, National Large Optical Telescope. The idea is to have a 12-meter mirror indigenously built by India and have it in the next 10 years. That's the plan. Proposals are submitted to the government. I don't know, but if it comes, we will have some. So this is how we have progressed. As I told you, when Galileo invented the telescope, the size of the telescope is only 37 millimeter. In 10 years down the line, when we have access to a 30-meter telescope, the size is how much? 30,000 millimeter. So we have gradually progressed from 37 millimeter to 30,000 millimeter, and this will become a reality in the next 4 or 5 years. So I just spend few minutes on the space program of astronomy. So as of now, I talked about the astronomy being done from ground. So we also have some heritage in space astronomy. I'll just quickly move through some of the slides. So our space program started with balloons. So instruments will be sent in balloons, and these balloons will be launched, and these balloons can travel high in the atmosphere. Data will be collected in the temperature. So this is how the thing started. And balloon facility was established by the Tata Institute of Fundamental Research in 1969. That was the basis for the space program. And from this facility, both northern hemisphere and southern hemisphere can be accessed. And using this balloon facility, experiments are not only conducted by India but by other countries also. This is the first instrument. It's a high energy imaging telescope. The range is 20 keV to 800 keV. And this instrument was successfully flown in 2005, 6 and 8. And this balloon has gone up to a kilometer of 41.4 kilometer. So this balloon will be gone. The then after some time it will accumulate data for some time and the balloon will come down. So we have to go and track the balloon, collect the payload and then analyze. This was the condition 2000. Around 2000 we had this. Again, the instrument was launched using TAFR and Japan collaboration. The launch happened in 1999. These are some of the. This is a summary of the space program. The human space flight was done in 2014, wherein Dr. Alam went up to an altitude of 41.5 km. And the balloon was designed by the Tata Institute of Fundamental Research, Bombay. And then there are animal space flight also, where live rats were in the balloon and the data being analyzed. Okay. And this is the first detection of X-rays coming from sources other than sun. 1975, India launched Aryabhatta, and the weight of the payload was 360 kg. And the objective was not to do any experiment. The objective was to just design and fabricate a space-worthy system. This is in 1975. Aryabhatta was launched. 1992 and 1994 saw the launch of SROS missions. These were done to study something called gamma ray burst. I told you about stars. There are certain resources called gamma ray burst. To study them, India launched the SROS series of satellites in 1992 and 1994. The Indian X-ray astronomy mission was launched in 1996, and that was made again with the Institute of Fundamental Bombay. And the success of this mission led to a grant mission which is called the AstroSat. And this is how it started. This will give you some idea of how projects basically generally happen in India. See, once the program is funded by the government of India, it takes roughly 10 years, 5 years to 10 years. So it is for 5 years. There are very many issues will come on the way before a successful launch happens. So this is a very important mission. As I told you, the concept happened in 1996. Many of the missions, the concept will happen only in dining table or lunch table. So people sit there, they come for a conference, they sit and discuss, ideas will emerge, and that will be taken forward. So the concept was in 1996. The DPR, detailed project report, was submitted to the government in 2000. The acceptance by ISRO came in 2002. Funding came in 2004, and the launch happened in 2015. Addition is a successful collaboration between ISRO, Tata Institute of Astrophysics, Physical Research Laboratory, Raman Research Institute, one Canadian institute, and a UK institute. So this is how it happened. And the beauty is, see, the sources in the sky are not stable; they change in brightness. So if you observe one source, and the lab is ground floor. These are the office spaces. And these instruments were located in the this is an image of a galaxy. Just a comparison. This is the old image from Galaxy, the NASA mission. This is the image from our own mission, UV8. You can see how much short this image is compared to this image. This resolution is 5 seconds. This resolution is 1.5 hour seconds. We are currently in the 10th year of operation, and there is no instrument which can do such nice imaging in the UV as of now. There are plans for future, but this is currently the best instrument available in space. This is another example. This is a cluster of stars. When you go to the night sky, you see individual stars, right? Stars are normally found in groups, so they come in clusters. This is an example how galaxy looks like and how UV looks like. So everything is resolved. Again, this is the ground-based image. This is the image coming from UV. You can see how different it is. All these bright points are from regions. Like humans take birth, they grow, they die. humans, stars also take birth. Stars are formed, and these stars grow. And as these stars grow, they also die as like human beings. Okay, these all are young star forming regions. Since they are young, they are very hot. As I told you, simply apply Planck's radiation law. If the temperature is high, they emit mostly UV radiation. So they are looking radiation. See these things. This is some of the selling point of AstroSat. See, it is in operation for the last 10 years. Only from ultraviolet imaging telescope, total 254 publications have come, leading to more than some 3,000 citations. This is how it is happening. After AstroSat, India also went into a major program called polarization. See, when you observe star or sun, you measure total light. Also, the light coming or photons coming from the stars are energy polarized. So, if you measure the polarization, that will give additional information. Though optical polarization measurements are available, X-ray polarization was not there. So, India tried to do a major program of having a mission, and we were delayed by NASA by only 1 year. So, both the missions are going parallel. We were delayed, so we launched later. And this mission was launched in, and our ISRO mission, it was launched in, okay, the ISRO launched in 2021, we launched this mission in 2024, so we are delayed by 2 years. Okay. The third thing which I want to focus on, Aditya L1. So father mentioned that we have the capability to go to sun. Okay. Aditya L1 has few instruments, and one of the instruments on Aditya L1 is called visible mission coronagraph. This instrument was designed and delivered to ISRO Institute of Astrophysics. I take the in simple terms. You see, you must have heard of solar eclipse. So solar eclipse means what? So when the view of the sun is blocked, the photosphere of the sun is blocked, and you see what is called the corona. And this corona can be seen only for a few minutes, and this can be done only during the eclipse. So the eclipse time, when the photosphere is blocked, in using the data, instead of studying the corona only in solar eclipse, what about the idea of blocking the photosphere? So if you block the photosphere, the corona will be always. That is the whole idea of this instrument. So what they do, they block the. You see, this is how it happens to eclipse, right? The photosphere is blocked. You are able to study the corona. And this, as I told you, this can last probably few minutes. But the instrument BELC, photograph, it blocks the photosphere, and we and this was 2023. All the we are having on the payload operations. The task of payload operations is from the data gets dumped. Means someone has to data was dumped. And once the data directly to Bangalore, so the group will be Bangalore analyze the data and send the data back to ISO. So this is about the current missions. So I just want to quickly conclude. So what are the missions for the future? So we started from Aryabhatta, space. Ground vehicle space started from Aryabhatta, successful mission, mission. ESCO-SAT was launched for polarization, and these are the missions for the future. One mission which is being planned is called Daksha. It operates in the X-ray range. Some seed money was allocated to ISRO. The second mission which is doing rounds is called INSIST. INSIST stands for Indian Spectroscopy Imaging Space Telescope. Imaging is an imaging system. So what you are planning, imaging, but these are under various stages of discussion, and some are at even advanced levels. Okay. The third thing is called ExoWorld. This is being led by the Indian Institute of Space Science and Technology in Toronto, a unit of ISRO. That is the from there, and the idea is to study extrasolar planets. This is a hot topic nowadays. So ISRO is also gearing up for it. Third is Satush. He is to do radiation in space. People from the Raman Research Institute are looking into this. The fifth thing which is being discussed at various levels in ISRO, various astronomical countries have a broad and polarimeter. There are also discussions happening, but probably the Chinese will overtake because Chinese are already having a plan to have a broad polarimeter. And in India, we are only in the discussion stage. So these are some of the missions for the future. And I just put one slide because it's on computers. I just put one slide on the role of computers in astronomy. Okay, computers are an integral of all we do. And this use of machine learning and AI happened in 1990s. Because you see, you have a telescope. Now what happened? People have designed cameras where the whole sky can be surveyed. So instead of studying one galaxy, you now have thousands of galaxies. So now we have thousands of galaxies. How to classify them? How to measure their parameters? This becomes a challenging task, and any individual cannot go and pick every source and study the parameters. So in these areas, AI and ML are having a major role. And I'll just give a summary. In the year 2021 only, there are thousands of astronomy papers written which uses AI and ML. Some of the examples where AI and ML can be used are given separation of sources into stars and galaxies. So I show examples. Stars are like point sources. Galaxies are what? Galaxies are collection of stars. They look very large. But if I take a galaxy and put it very far, the galaxy also looks like a point source. If I take a source and put very far, it also looks like a point source. So in my image, separating a star and galaxy becomes very difficult, though we can do manually. So one place where AI and ML tools have a major role is to separate these sources into stars and galaxies. Second thing is classification. If you talk about galaxies have different shapes. Some is spiral, some will be elliptical, some will be irregular. So humans can do the classification by seeing and something. But if you have a survey, it's very difficult to do the classification, and there AI and ML are playing a role. Physical identification of objects, how to identify objects. These are the places where AI are playing a major role. And since students are assembled here, I just put one slide what the future looks like. I have clearly shown two examples. India has demonstrated the capability to do astronomy from space. There are ample opportunities for students. Okay. And astronomy is pursued by many institutions in India. As I told you, competition is tough. Selection is rigorous. So just because since students are here, I just want to give a glimpse. Competition is tough, selection is rigorous. And astronomy is now pursuing Indian Institute of Science, many ISS in the country, and even two colleges in Tamil Nadu and Kerala and Karnataka are doing astronomy. And Christ University in Bangalore, they are having a good astronomy department and they are doing nice there. These are some of the institutes for people who are interested to do astronomical research in the country. These are some of the opportunities what is given for students in the Institute of Astrophysics. So we normally take students to do PhD, and the entry is to just net 10 gate. The fellowship is 37,000 rupees for the initial 2 years, and after 2 years again you have an interview where you will be assessed whether you are eligible or not. And once you qualify that interview, you will be promoted from JRF to SRF with a fellowship hike of 42,000 per month. And in IAA we have decent hostel facility, And if you don't want to stay in the hostel, you are given a HR of 30%. 30% HR will be given, you can stay outside. And what at IEA? You can, as I told you, there are 2 times you can enter IEA. One is in December, other is in June, January, in July or August. And in addition to PhD, you can do short-term projects. You can visit our institute for a period of 3 months or even 6 months. And during this period, you will be given a fellowship of some 15,000 rupees per month, but accommodation will not be given. And people who are doing MPhil in some institutes can come to our institute for a maximum of 6 months. PhD students who are enrolled for PhD in other institutes can come to our institute 3 months in a year. So in 5 years, they can come for a period of 15 months total. And we also have summer programs. And the summer program will be conducted in our observatory in Kodaikanal for a period of 15 to 20 days. And this selection also will be a nationwide selection. And for more information, you can visit our website. And the thing what I want to mention is, you see, India is embarking on major projects. As I told you, see, these are some of the projects which we are planning. If you talk of space, we are having plans for Daksha, we are having plans for INSIS, we are having plans for ExoWorld, we are having plans for Pratyush, and there's a plan for a broadband polarimeter. If you talk of ground-based instruments, so in terms of ground-based, we have plans for a national large optical telescope, and we are having plans for 30-meter telescope project. So these are some of the upcoming projects in astronomy, and all these projects require a lot of people. So we need mechanical people, we need optical people, we need electronics people, we need computer science people. So people from different branches are needed, and though it is there, the number of people they select is very, very specific. Okay. So anyway, you keep an eye on all these things, and this is just an advertisement which came recently. This is about the summer school which we are organizing in Kodaikanal, and the deadline for applying is 12th. So I think I will close here, and if there are any questions, we can discuss. No questions?
Thank you, sir, for your insightful keynote address on astronomy. A warm smile is the universal language of kindness. I now invite Ms. Shirisha of 3rd BCA to extend a gracious welcome to our second keynote speaker.
Good morning. We now came to a moment of great anticipation and opportunity to hear from a truly extraordinary individual whose wisdom spans the domain of entrepreneurship, academic leadership, and sustainable innovation. It's a privilege to invite the second keynote speaker of the day, a stalwart in the field of management, an inspiring voice in responsible business practices. Dr. Matthew G. Manimala is a distinguished management scholar whose career spans decades of academic excellence, thought leadership, and institutional transformation. With credentials from premier institutions at MBA from Cochin and MBSc from Manchester Business School and fellowship from IIM Ahmedabad, he brings a rare blend of global perspective and local insight. He served as a director at SIME, Bengaluru until his retirement in 2018. Following a prolific tenure of IIM Bangalore from 2001 to 2015, where he held esteemed positions such as Jamuna Raghavan Chair Professor of Entrepreneurship, Chairperson of NSRCEL, and the Chairperson of OB HRM area. Previously, he held academic roles roles at the Administrative Staff College of India, Hyderabad, CUSAT, Kochi. Dr. Manimala's scholarly impact is evident in his 100+ research papers and case studies, 12 published books, and accolades such as Hazard Award, the EFMD Fellowship UK, the Best Professor Award from CMO Asia and ET Now. Most recently, in 2022, he received the Bestseller Case Award from Ivy Publishing Canada. He currently serves on multiple academic councils and editorial boards and has been the editor of the South Asian Journal of Management since 1999. A luminary in entrepreneurship, organization behavior, and sustainable strategy, Dr. Manimala continues to inspire his commitment to impactful, ethical, and future-ready business education. With a great honor and anticipation, I now invite Dr. Matthew J. Manimala to grace the stage and deliver his keynote address.
Thank you for the kind words of introduction. I'm happy to be here because this is a special conference which integrates or attempts to integrate scientific knowledge with management and other issues. Now, after a very scholarly scientific presentation by Dr. Stalin covering the entire universe, I think we should come down to the earth for a while and talk about how to make the earth greener. Because I am not at all a technologist, I thought I would focus on the green initiatives. I am not green technology, but the green initiatives which have been going on, particularly some innovations in the field. Now, if you look at the kind of ideas that are going around, we in India are exceptionally good in proposing ideas, but I don't know to what extent we implement them, particularly innovative ideas. Of course, I may get disturbed in between a little, even though I was selected, fortunate to be selected as the best HR professor in Asia and also in India, Bombay also, twice, 2001 and 2013. I don't know how I got selected that way. One was CMO Asia, Singapore. The other one was ET Now and World Education Congress. Anyway, but in spite of that, I qualify myself as a disabled professor because, as you know, the most important organ that is required for in the academic profession, teaching profession, is your lungs and your throat. Both are disabled for me. I have very serious allergy, bronchial allergy. Then the second thing is the legs. I had right from the childhood very weak legs, so I never used to run around and play and all that. And that was, you see, when you have in entrepreneurship, you say if you have a disadvantage, some kind of constraint, that will be the time when you convert it into an opportunity. That is what most entrepreneurs do. Now, this happened in my life, not deliberately done, because I was not able to go around and run around and play. I used to pick up any kind of magazines and all that available because my father was a writer, so plenty of small magazines and all those kinds of things were available. So I kept on reading. So developed a habit of reading right from my childhood, and that I said was the kind of advantage that came to me from a disadvantage and a constraint of not being able to run around and play. Now, what I was saying was that because of this kind of a disability, sometimes I sit down and speak. Of course, here it is not a very long kind of a session, so there is not needed that way. But because of that, you know, in the teaching situation, it is the faculty who has to stand. The students are sitting and relaxing and enjoying, isn't it? That is the situation in a teaching situation. Therefore, you know, a disabled professor like me may not be able to entertain you for a long time. Now, because we had a very, very scholarly presentation, in order to bring you down to the ground, let me ask you some. In fact, I used to ask some logical questions about chemistry because, you know, I had this nagging doubts that chemistry may not be a good science because they don't, at least the elements don't follow the logical kind of reasonings. Now, for example, we know that hydrogen is gaseous. You can think about this, but no need of answering this question. Even a chemistry professor could not answer me. The hydrogen is gaseous, oxygen is gaseous. Both are combustible. They, you know, fire, cause fire, and all that. But then when they join together, it becomes in a liquid form. And water, you know, is used for extinguishing fire, whereas it doesn't have any properties of these two parents. That was one question. So why is it so? The second question I used to ask was about related to this one. That is, you know, H2O is water, isn't it? Water is very much needed for sustaining your life. But then oxygen is also very much needed for your sustaining your life. But to H2O, if you add one more oxygen, it becomes H2O2, hydrogen peroxide, a dangerous gas. So why is it so? Both two life-sustaining elements combining to, you know, become a poisonous. So anyway, this is for you to just lighten the moment and for you to reflect later on, maybe when you have time. Now, coming back to our topic of green initiatives, you know, we all think that most other power generation systems are polluting, except maybe solar or something, because all other things like thermal power, you burn coal and, you know, produce carbon dioxide and all kinds of issues are there. Even even the hydroelectric projects, there are problems for the ecology and all that. But solar, they say, is absolutely not much of a problem. And therefore, long ago, once when I was in Administrative Staff College of India, we got an assignment for evaluating a particular government scheme for using the solar energy to convert it into an electric this thing and helping the villages, because remote villages, it is very expensive to have electric line drawn up to the village, and therefore you know, they thought that if you install solar panel based lighting in the villages, few of them, that will enlighten the place. And they installed several such in several villages. Got an assignment for evaluating that. This is in the 90s, as early as that, so not a recent one. So we went there. You know, what a shock it was. Government has spent a lot of money in order to provide this kind of lighting for the villagers, but none of them were working. Now, can you guess what is the reason for that? Because, you know, solar energy comes only during the daytime, but we need the power during the night time. So it has to be stored somewhere, and for that you have to have a lead acid battery. And lead acid battery, even though solar energy is not polluting, lead acid battery is extremely polluting, particularly when you throw it after the use. The disposal is really polluting. So this was, the situation. You had to have this battery, but the problem was that the villagers were not instructed as to how to maintain this battery. You need to periodically pour distilled water or something in that, and keep it alive. This was not done, and nobody from the government system never came for after sales service or anything like that because it is a government system, and therefore every battery got dead, and therefore lights were not burning. So this was the kind of situation. So when we look at something, we may have to think of the whole process and then maybe educate the consumers or the villagers about that. Now, that was a time when I had an opportunity to go to Germany, and there I found they were eliminating the battery not because it is inconvenient. Those people knew how to maintain all that, but they said we wanted to eliminate this lead acid battery, no storage, because it is polluting in the long run. And therefore, what they did was they asked in those days, they had a scheme, 1,000 household scheme that was subsidized. That is, on rooftop you have a solar panel from which you generate electricity. So there is again another problem. Electricity is generated during daytime, and therefore you need to use it at the right night time. When people are not there at home during daytime, they go to office. So what do? You have to have battery. Then they found an innovative solution, and this is why what we are saying, the innovation may be simple, but then coming out with that and implementing that is something which is missing in our country. What they found did was, instead of having the battery, they said we will have 2 meters. One from the electricity, the equivalent of the electricity board, for the power that you are getting, the other for the meter to measure the power that is going out of you. You are into the distribution system. So you can supply electricity to, if you are not using it in your place, you can supply it to the system, and then you can utilize the electricity from the system at night when you need it. So this was the way they managed it. And then if you are finally when you are paying the bill, the difference between what you supplied and what you got, that is charged. And very often households used to get money out of that. So they started subsidizing only 1,000, but then by the time I was there and looking at all this, they had more than 25,000 households involved in this, and it was growing. So this is the kind of small innovations which help you to do this what we call the green initiative. Now there is another kind of innovation again which doesn't pollute in the energy sector. That is called the wind turbine. You erect a wind turbine and they generate, and this is done in the Netherlands. Netherlands is called the Netherlands because it is lower than the water level. That's why it is called the Netherlands. So when there is rain, water doesn't drain off. Now, instead of filling the whole area, what they did was they set up wind turbines, and then whenever there is rain and some water, they just pump it out using this wind turbines power. So that was an interesting thing, and somebody from here went and looked at it and then said, "Oh, we should do it in India also." At that time, the New Bombay was developing. So we had a consultancy project there also from Administrative Staff College of India. So when they said we are going to install this kind of wind turbine, and they did that. But in India, or particularly in that Bombay, this was in the Thane area. Beyond that, the valley of that place. Monsoon comes, particularly in Bombay, only maybe 2 weeks of heavy rains, and the kind of water that collects cannot be removed by this wind turbine. Whereas the rain pattern in the they say the English weather and the English maid are fickle, which means it comes for a while and then goes. The mood changes. That's all. That's nothing more than that. So the same kind of rain is happening in the Netherlands also. Throughout the time, as we have here, they don't have a rainy season, and therefore, anytime it can happen, and the water collection will be less, and it can be, pumped out. Now, this is not possible in this kind of a situation like in India, where the monsoon rains are very heavy, and the whole area is flooded. So this is something which even when we see some innovation abroad and try to implement it here, we don't really make it conducive to our situation. So that is another issue I would like to point out. Then the third one, I'm talking about the electric vehicles. That also they say it is pollution free, it doesn't emit any smoke and carbon dioxide and those kinds of things. So pollution free, isn't it? But where does it get the electricity to charge this vehicle? That is from the system, isn't it? And most of our electricity generation, except for some the hydroelectric projects, most of the other projects are thermal based. It is coal based and those kinds of things, emitting lot of the carbon dioxide and other kinds of polluting it's in the atmosphere. But then what you are really doing by using an electric vehicle is only shifting the pollution from here to some other place. Somebody is getting polluted, and then you are using the electricity here, and then saying that I am not polluting. You are also partly responsible for polluting that, isn't it? So, how do you manage that? That also I came to know, from a visit to China. Everybody here in our since you are all students of science, even otherwise in schools you learn that there are certain things like graphite and diamonds are all carbon. Different forms of carbon. And you say carbon dioxide is bad, but in your own human body you need carbon, carbohydrates and those kinds of stuff. So it is not something to be eliminated. But just like what I mentioned about hydrogen and oxygen combining and becoming water and changes its entire quality, you should also combine this with something else and change its quality. And then it will not be a polluting stuff. So what they have done is, in large industrial complexes and all that, they collect these emitted carbon dioxide and then do some processing. I don't know what they do, but finally convert it into diamonds. So if it is given to you as carbon, you will not touch it. But if you are given as a diamond, all ladies will fall for it. So this is how you convert your polluting agents into value-added projects. And that is how you need to deal with the situation. Now, there is another issue, as I mentioned about the electric vehicles. The other problem with it is the periodic need for charging it. Now, for charging it, you need to have some interruption in your journey and all that, and therefore, it is still not very convenient. You know what the Chinese have done? They have set up solar panels on top of these electric vehicles, so that when you drive during the daytime, your battery gets automatically charged. And therefore, you see, what a great kind of innovation. We never thought about it. We never have done anything of that kind. So these are some of the things that, unless you think about and try to do innovations, all these talks about being green, etc., are not very productive. Now, uh, lastly, let me talk about some industrial kind of application uh, of this kind of concept of converting, waste and polluting kind of things, and making use of it. In this is again another visit to a place in Denmark. The place was Kalundborg. You can, if you Google search, you will find that there is something called Kalundborg Eco-Industrial Park. They were the first ones to do that. Now we have many industrial estates, but almost every industrial estate will be having similar kind of units. One is a chemical industrial estate, or the other one is this one or that one. Similar ones are put together. Now, eco-industrial park concept in Kalundborg was something different. They said, we will have a major industry here, and the waste of that, there will be some other industry which will be utilizing the waste coming from out of that. So those kinds of units will be kept in the vicinity. And this was not a government initiative at all. This was a private initiative where these people thought about it and then say we are having a major plan for energy generation, electricity generation, and for that around that they set up other units. It's very difficult for me to remember what all other things they were utilizing. But one is, for example, the surplus heat. There will be surplus heat in that particular plant. That they distributed in those countries. You need to heat the households. So they distributed it to 3,500 families. To heat those families at a very, very subsidized rates, so that the kind of what you call heat pollution in this area will not be there. It is controlled and conducted into the heating system of the households. That was one thing that they did. Recently we were writing a case study on a company called Lorman Kitchen Equipment Limited. What they have done is, they have, for large industrial kitchens, they have introduced induction cooking. And one specialty of induction cooking is that the heat will not be outside. In major kind of other kind of system, gas heaters and all that, they say you are actually heating the chef, not the food. Food also is getting heated, but then more important impact on this one is on the chef, and therefore it is actually detrimental to them. So induction cooking, this will not be there. So something similar to that they were utilizing, and then try to control this and send it to households. That was one thing they did. The second thing, the sludge coming from the, they were also trying to do this heat distributed to fish farms. And the sludge coming from the fish farms were utilized as organic manure. And then the steam from the power plant is used and sold to Novo Nordisk. You must have heard of this company's name. That's a pharmaceutical company. They utilize the steam that was emitted out of this major power plant. Similarly, the sulfur dioxide, that was a major issue from the burning of the carbon. Carbon has got this sulfur part of it. So sulfur dioxide comes out, which is a harmful they take it out, and there's a plant which converts it into some boards, kind of thing. Then the fly ash from the power plant, that is being used by a cement company for making cement. You see, now no waste is going out of that power plant. Everything is being utilized by other industries. This is how they designed that eco-industrial park. Now, think about in our country, how many eco-industrial parks do we have? We don't have any. So, I would like you are all youngsters, very bright youngsters, doing your studies. But in addition to getting this understanding about what is, being taught in the class, think further and then try to generate innovative ideas and then use that for dealing with the problem about pollution and other kinds of issues. So I wish you all the best, and it is already quite late. Thank you for your being patiently.
Thank you, sir, for your inspiring words. Appreciation is a wonderful thing. It makes what is excellent in others belongs to us. To acknowledge the mind that enriched our seminar, we invite Reverend Father George Todal CMI, our beloved manager, accompanied by our dear principal, Reverend Father Jins George CMI, followed by Mrs. Lakshmi, Head Department of Computer Science, and Dr. P. Rajalakshmi, Head Department of Science, to the stage. Now it's our privilege to invite Dr. C.S. Stalin, Professor IIA Bengaluru, to accept the token of appreciation from us. Sir, please. Thank you, sir. And now I cordially invite Dr. Matthew J. Manimala, former Director of Science and former Professor at Bengaluru, to receive our love and gratitude. Thank you, sir. Thank you, Father.
Thank you, everybody.
Let us remember, one book, one pen, one child, and one teacher can change the world. As we conclude this inaugural session, let us carry forth the promise that knowledge, when aligned with the conscience, can transform the planet. Thank you for your presence and participation. I request everyone to rise for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल
students to keep on standing for the photo session. Now I request our dignitaries, panel members and teachers to join us on the stage for the photo session.
Still going on? I see. And off. Still. Where do you bicycle? Ah, there. Laptop.
Treat you like cattle, use you as cannon fodder. Don't give yourselves to these unnatural men, machine men with machine minds and machine hearts. You are not machines, you are not cattle, you are men.
We can up.
Am I audible to you?
Yes, it's audible.
Then who's ready now? I'll read out the ID. NS101, NS102, NS103,
Ma'am,
NS105 and 7. Ma'am,
hello, ma'am. Good morning.
your good morning, your paper ID, ma'am. Gayatri, ma'am. Paper ID?
Yes, ma'am. NS 103.
103. Okay, ma'am.
Yes, ma'am.
So, can you share your PPT, ma'am?
Yes, ma'am.
Okay. Judges, paper ID is
Okay.
103. I have one more.
Ma'am, is it visible?
No, ma'am. It's not visible. Yes, ma'am. Is visible.
Yeah.
Yes, ma'am.
Am I visible, ma'am?
Ma'am, excuse me, ma'am. Gayatri, ma'am.
Yes, ma'am.
10 minutes will be given, ma'am, for the presentation, and 5 minutes will be for question and answer session. Kindly stick to the timing, ma'am.
Yeah, fine, ma'am.
Shall we start?
Yes, ma'am.
Okay, thank you. You
So,
can start, ma'am.
first of all, good morning to all the delegates. And first of all, thank you for giving me this opportunity. And here I presented my research paper. I have done my MSc Integrated Food Technology in Sri Padmavati Mahila Vishwavidyalayam, Tirupati. And this is my research title, Banana Stem Core Biscuits, Healthy Sustainable Green Technology Solution to Agro Waste. So, coming to the introduction. Excuse me, sorry. It is not sharing the second slide.
Ma'am, enable editing option, ma'am,
Okay, ma'am, okay.
in your screen. Top.
Yeah.
Screen is not visible. Gayatri, ma'am.
Yeah, ma'am.
One second.
Ma'am, just a second, ma'am.
Otherwise, shall I present it, ma'am?
Ma'am, the second slide is not moving.
Yeah. Yes, ma'am, it is visible, ma'am. Change the slide. Second slide.
Yeah. Yeah, ma'am.
Yes, it's slideshow, ma'am.
Yeah, okay, ma'am.
Okay, 12 says, ma'am.
Yeah, coming to the introduction. So now every year billions of tons of agricultural waste are produced worldwide. So this waste includes crop residues like straw, husk, leaves and stalks beside animal manure and other organic materials. So conventionally, much of this waste has been burned or left to decompose. So releasing carbon dioxide and methane into the atmosphere. So proper management of agricultural waste is crucial for sustainable farming practices, helping to reduce environmental pollution and improve farm productivity. So, although technological development and a growing focus on sustainability has given rise to the development of methods to convert this waste into renewable energy. So, coming to green technology. Green technology is a term which came into limelight when the world felt that there is urgency in the direction of environmental and ecological stability. So there is no such exact definition of green technology, but United Nations defines green technology as technology that has the potential to significantly improve environmental performance related to other technology. So it is related to the term environmentally sound technology. So coming to the bananas. So bananas stand among the worldwide generating fruit crops because farmers cultivate stand among the worldwide leading fruit crops because widely in tropical and subtropical regions. So behind the familiar fruit, many parts of the banana plant, especially the central core of the pseudostem, so gives both nutritional and economic benefits. So the soft innermost part of banana plants remains unseen from commercial cultivation, even so contains extensive nutritional value that people across Asia, Africa and South America have been used for both medicinal treatment and dining purposes. So, so this is the methodology of preparation of banana stem core flour. So first of all, procurement of banana pseudo stem. So a fresh sample of banana pseudo stem was collected from the nearby fields and the banana center core was removed separately. So the separated banana center core was washed thoroughly to remove surface dust and dirt. Later the core was cut into uniform sized pieces. Browning was a major problem with the banana center core and hence to avoid such problem. So the pieces were soaked in 0.2% potassium metabisulfate solution, which was drained out and removed the pieces. So the pre-treated pieces were subjected to drying in hot air oven at a temperature of 70 degree centigrades till the maximum removal of moisture. So the dried pieces were then blended into a homogeneous mass in a blender. Now banana stem core flour was ready for use. So the prepared banana center core flour was packed in a airtight container and further used for the product development whenever required. So this is the banana stem core flour preparation flow chart and how to prepare masala biscuit making procedure. So first of all, we all know how to prepare biscuits, but in this I blend banana center core flour in the biscuits. So sieve the flour with baking powder thrice, then add banana center core flour and masalas into it and then sieve for proper mixing. So cream butter and powdered sugar till light and fluffy, adding essence. So add flour gradually to make a pileable dough. So roll out into 0.31 centimeter thickness and cut with a biscuit cutter and separate the biscuits. Grease the baking tray and keep the biscuits. So bake at 195 degrees centigrade for 15 minutes. And standardization of the product. So, composition of three different trays for standardization of value-added banana stem core masala biscuits. So, I had took M1 variation is 2.5 grams of BCC flour and M2 is 5 grams of BCC flour and M3 is the 7.5 BCC flour. These are the three different variations to prepare the BCC biscuits. So this is the sensory evaluation. So sensory evaluation is the first and foremost criteria to determine the acceptability of any product before releasing into the market. So hence during the present study, the sensory evaluation was done to standardize the value added product. 5-point hedonic scale was adapted to evaluate the product. So the panel comprised of 30 skilled panel members from the Department of Home Science. Based upon the mean organoleptic scores, the product was standardized in view of the essential organoleptic parameters like appearance, crust color, crunchiness, taste, texture, odor, and overall acceptability. So the organoleptic scorecard was provided to the panel members and requested to fill it as per the instructions given. So the 5-point rating scale is this one. So 5 means excellent, 4 means very good, 3 means good, 2 means fair, and 1 means poor. Yeah, previous slide, this is the banana stem. This one green color. The innermost core is the banana center core. So I have prepared this one, banana center core flour. And the standardization of the product. So here are 3 different variations were worked out to standardize the value added product by substituting the wheat flour with banana center core flour at 3 different proportions. So it's take 5%, 10% and 15% respectively. So sensory evaluation is okay, done. And next, nutrient analysis. So the nutrient analysis was estimated at the laboratory as per the standard process, both for reference sample and as well as standardized value added product. So the essential nutrients analysis during the study period with moisture, I texted moisture content, protein content, fat, ash, calcium, and the microbial quality analysis. So apart from organoleptic quality, the product must be checked for the microbial quality evaluation to consider the food safety of the product to be consumed. Hence, the current research was also aimed at microbial quality analysis, that is total viable count, yeast and mold growth, salmonella and staphylococcus. So next one is shelf life study. So was conducted for a period of 1 month only at fortnight intervals. At the present study was of short duration. So the quality of the product was evaluated during the storage periods in terms of both organoleptic evaluation as well as microbial quality analysis. So and results and discussion. So here the overall study comprised of converting banana center core into flour, developing value added products, analyzing nutritive value and testing for quality characteristics and shelf life stability. So the results obtained were discussed. So here the organoleptic evaluation of BCC value added masala biscuits with different variations M1, M2 and M3. So here the M2 is the standardized product. This is the overall acceptability of the 3 variations, and so the results from the above table over a period of 1 month estimated through one-way ANOVA test statistically revealed no significant changes over a period of 1 month in all the organoleptic scores irrespective of the value added banana center core biscuits developed in the study. So thus the observations on the organoleptic shelf life study test provided definite evidence of at least 1 month shelf life period for the 3 variations of biscuits. So, however, the study can be extended to ensure the accurate shelf life period for the developed value-added products. So, here the nutrient analysis of BCC masala biscuits. The moisture percent is 9.72 and the protein is 5.85 grams and fat is 21.42 and ash is 0.25 and the calcium is 53 mg and iron is 2.41 and beta carotene is 186.80. And so this is the shelf life study through microbial quality evaluation. So shelf life study, the microbial criteria that often used by the food industry or a regulatory agency to monitor the quality of the product. So the results on microbial quality parameters evaluated in the 3 varieties of value added biscuits not showed any microbial growth for a period of 1 month. So this indicated a certain on food safety for 1 month period for the biscuits. However, the study need to be extended to arrive at the exact shelf life period of the value added biscuits developed during this study. So here there is no microbial growth in the masala biscuits after 1 month. And this is my research study, and this research explores sustainable green interventions designed for agro waste, which indicate innovations that benefit human health and environmental health parallel to healthy, sustainable green technology. So this study aims to achieve beside objectives by identifying strong waste management solutions that scale up and remain cost effective. So thus helping the agriculture industry move to more eco-friendly practices while encouraging global implementation. And thank you so much.
Thank you, ma'am. I will hand over the session to the judges.
Yeah, okay, ma'am.
Yes. Madam, it's overall a good presentation. So I have I have two questions. Okay.
Yes,
The
sir.
first thing is, do you have any plans to market and do marketing of this product?
Sir, actually, this research is done my actually 5 years back, and at that time there is no idea to produce in the market. So in future, I will do my PhD. So after PhD, I will think to
No, no, it's okay.
market my product.
Correct, madam. This is a good thing. Suppose if the product has come good,
Yeah.
will, what are the other procedures you have to follow to market this product? I'm just asking, just for curiosity.
Okay. Actually, first uh, I have to take patent, sir.
Okay, you have to apply for. No, you will publish as a research article, no, first.
Yes, sir.
Then you will apply for patent.
Yes, sir. Yes, sir.
Once you get the patent, you can bring it out as a product, or but to bring out as a product, you have to get some license also from municipality or panchayat, na?
Yeah,
No.
food license, sir. Food license in FSSAI, Food Safety and Standards Authority of India.
Yeah. Now my question is, since you have come up to this stage, what
Yeah.
are the other difficulties you are facing to bring this to a market?
So
Do you
first
need
of
to
all,
do more work?
yeah, first of all, I will to check another analysis also, sir, another nutrient analysis, the fiber content
Okay.
and
Okay.
shelf life period. Before I tested only 1 month.
Hmm.
So here I have to check for 6 months to 1 year. So after 1 year, is there any microbial growth and the product isn't good, or it's is there
Hmm.
any bacteria? So I have to check. So these are
Okay.
the difficulties, sir.
Okay, madam. Agreed. Agreed. This is a good idea, but if you can bring it to something
Yeah.
right thinking, it will be. This is just a thought. This is one
Yes,
thing.
sir.
One more question I have. You have carried out some ANOVA analysis.
Yeah, yeah, yeah.
What is the basis of that whole analysis?
So
It's a
what
statistic.
you
It's a
are
statistical
asking?
test. Na? Is it a statistical test?
Yes, sir.
How does it function?
So actually, it's differences between groups and are due to chance are statistically significant, and
Hmm.
more than two groups, it's need to ANOVA test.
So how is this test performed? Are you using a standard code, or you developed your own code?
So no, sir, no own code. This is standard code.
No, no, you are using some standalone code available for this ANOVA analysis.
Yes, sir.
This is analysis of variance, na?
Yes, yes, sir. Analysis of variance.
So these are standard Python codes, or you developed yourself?
No, sir, no Python.
Okay, can you tell the principle how it works?
Yes, sir. Yes, sir.
Can you let me know the principle how it works? This analysis.
So this analysis, it's
I'm just curious to know. That's it. How it works.
actually it's a tool used in statistics, sir.
Agreed, madam. But just I want to know the basic principle of this whole method. It's a statistical tool. I agree, but anyway, that thanks for that. But anyway, say
Yeah.
piece of work. So I am not an expert in this, but I would like, if this is coming out as a product, it will be interesting to look out.
Yeah,
Thanks. I
yeah.
have no other questions, madam.
Yeah. Okay. Okay. Thank you, sir. Thank you very much.
Okay, Gayatri, it was a nice presentation.
Okay. Thank you, sir.
So, a few questions. Are there any non-health benefits or risks associated with the consuming banana stem core?
Sir,
Are
please
there
ask me.
are there any
Father,
non-health
your voice
benefits?
is very low, Father.
Pardon?
Sir, your voice is so low, sir. Please ask me once again.
Am I audible now?
Yes, sir.
Okay. Are there any non-health benefits or risks associated with the consuming banana stem core?
It's a non-health benefit, sir.
Yeah, non-health benefits or risk.
Sir, actually, it's very health. Actually, it's good for kidneys, and it's very high in moisture content. And non-health related issues are very low, sir. It's actually a traditional medicine. It's also been used as a traditional medicines, and it's non-health benefits. It helps in weight loss and constipation and improves gut health. Actually, it's rich in fiber. Actually, it's a superfood, sir. Non-health benefits is nothing, sir.
Okay, good. Then, were any preservatives or additives used in this formulation?
No, sir. Actually, the banana stem core is openly. It's browning. It changes the color and brown color, sir. So we prevent that brown color. So we soaked in 0.2% KMS solution, sir.
Okay. Thank you.
Yeah.
Thank you.
Okay, Gayatri, your presentation is good. I have one question.
Yes, ma'am.
What support do you think is needed from policymakers to promote agro-waste based food innovations?
Ma'am, please once again asking,
Yeah,
ma'am.
what support do you think
Yeah.
is needed from policymakers to promote this agro-waste based food innovations?
One second, ma'am. Ma'am, generally, agro waste can significantly support food innovation and by providing a rich source of raw materials and valuable compounds, ma'am, to developing new products. And so agro waste is also used for food packagings, and actually this banana pseudo stem is particularly high in cellulose, ma'am. So this banana stem has more byproducts, and actually this make yarn and mats, and it is used as a textile industry also, and it has very good absorbent of water, ma'am.
Okay. Thank you.
Okay, thank you, ma'am.
Thank you, ma'am. Thank you, judges. Can we have the next participant? NS101 paper ID. Bindu, ma'am. Yes, 101 is ready. You requested that you have some PhD related exam. So we will be preponing your presentation first. We will have. Yes. Paper ID 101 is ready. Paper ID 102. Indu S. Nair. Ma'am, your presentation is ready. Paper ID 105 or 107. Participants, let me know whose presentation is ready.
Ma'am, 104 is here.
10?
104.
104. Chemistry. Okay, ma'am, fine. You'll just share the screen.
Okay, thank you.
Panel members, paper ready NS 104.
Okay.
Is the presentation is clear?
Yes, ma'am. It's clear. You can start. 10 minutes for the presentation, ma'am, and 5 minutes for question and answer session.
Okay, thank you.
Thank you. You can start.
Good afternoon, everyone. Here I am going to present about the topic sustainable cellulose nanofiber extraction from Boracis falciparum, a comprehensive study and analytical results. In the introduction part, I have conducted my research on Palmyra palm. It's known as Boracis falciparum. It's in the Acacia family. Although in this research, I have conducted the cellulose production, and the Palmyra palm is also known as the tree of life, and it's due to its diverse applications in food, beverage, biomedicinal, and lumber production. Although this study deals with the analysis of nanocellulose extracted from Palmyra fruits. As we all know that cellulose, let us know some properties of the cellulose. Cellulose is the most abundant natural biopolymer, and that can be isolated from wood, plants, algae, tunicates, bacteria. And it's a linear polysaccharide with one full linkage arranged in crystalline. It both in crystalline and amorphous forms are seen. Thus, the nanocellulose has outstanding properties, including high aspect ratio, crystallinity, thermal stability, biocompatibility, etc. How the nanocellulose is extracted from the Boracis falciparum. First one is the sample preparation, second is the pre-treatment, and third is the acid hydrolysis. In the pre-treatment, it includes alkali treatment and the bleaching process. It will be explained in the upcoming slide. This is a schematic representation how the cellulose nanofibril is extracted. At first, the Palmyra fruit, it's converted into the raw sample, and then it's undergone the alkali treated sample, and then bleach the sample. Thus, by homogenization, we will get the Palmyra fruit cellulose nanofibrils. In the resultant discussion part, we can discuss the mechanism of this process. Mercerization is the first step. The raw sample, about the 50 gram of the raw sample, is treated with the 2000 ml of 2 liter sodium hydroxide for 3 hours at 80 degrees Celsius. It's mechanically stirred, and thus it's repeated for 2 more times. Using distilled water, it is washed, and then it undergo the bleaching process. That the bleaching process is treated with sodium hydroxide with 200 ml of 10% to sodium hydroxide, 15% 1000 ml hydrogen peroxide stirred mechanically for 3 hours, and it's also repeated for 3 times. Next step is the acid hydrolysis. Acid hydrolysis means the bleached sample is treated with 5 weight percentage oxalic acid in an autoclave at 121 degrees Celsius and 15 psi pressure for 15 minutes, and it's all repeated for twice. At last, the homogenization step. The the acid hydrolysis sample product was washed and homogenized with distilled water. At last, we will get the Palmyra food cellulose